Okay, so let's do part A. Calculate how high it goes. Ignore air resistance. So we want to calculate how high this ball goes. Okay, so for these problems, you can pick the path, how much of the path you want to look at. So you can just look at the ball going up, or just from the ball on the top to down, or the whole path. You can choose what portion of the path, the ball's path, you want to look at. Okay, so I'm going to choose just where the ball is from point A to point B. Point A to B. Okay, and I want to find how high the ball is going to go. I'm going to make the positive y direction in the path of the motion of the ball. So I'm going to make upwards as positive y direction. That means, well, acceleration of gravity is always downwards, but that means acceleration is negative 9.8 because I made the direction upwards as positive. Okay, so I want to find y. It says initial velocity is 10.0 meters per second, so the woman is throwing up the ball with speed. So for the previous problem with the boy on a platform just stepping down from the platform or just dropping a ball, those are velocity initial equals to 0 because it's just dropping the ball or stepping down from the platform. You're not dropping down with initial speed. So if the problem will tell you if there's initial speed. So for our problem, she's gonna throw the ball with initial speed. So it says initial velocity is 10.0 meters per second. Okay, so always draw the diagram and write what you have. At the top here, velocity is 0. So write down all the things you have here. Initial velocity is positive 10.0 meters per second. It's going upwards, see? And upwards is positive. So positive 10.0 meters per second. I want to find y. Acceleration is negative. And y naught is the bottom right here. Y naught equals 0. So I have those 5 equations, and you just try to figure out which one do you want to use. So I have these 5 equations. For this average velocity, I have initial and final. So I can find average velocity for this. 10 plus 0 over 2, so 5 meters per second. And then I can plug it into this equation. But I don't have time, so I can't find y. So this is not we can't use this equation. Okay. So for this equation, I have y naught. I have v naught. But again, I don't have time, so I cannot calculate y. So this is also not or I can't use that equation either. So which equation should I use? If you use this equation, I can find y. Okay, so just plug it in. V squared equals v naught squared plus 2a y minus y naught. Just plug in what you know. V on the top of the path, v at the top of the path, the final v is 0. So, and then V naught is 10. So 0 equals to 10 squared plus 2 times negative 9.8 times y, and then y naught is 0. Okay, I'm going to subtract the 100 equals to 2 times negative 9.8 y. So negative 9.8 times 2 is negative 19.6 y equals to negative 100. So y is 100 divided by 19.6. So that's 5.1. 5.1 meters. Because everything's in meters per second. The velocity is meters per second, so meters. So 3 sig figs, so 5.10. So this ball is going to go to a height of 5.10. Again, I chose to only look at this one, the beginning initial part of the ball's path. You can choose whether to look at it going up or down or the whole path. You're supposed to get the same answer. Okay. Now let's do part C, because part B, how long is the ball in the air before it comes back? So part B is asking this whole time from A back down to C, what is the time? Part C is going to say how much time does it take for the ball to reach the maximum height? How long does it take to go from point A to point B? I'm going to calculate that first, and then I'm just going to multiply it by 2 to find the whole path. So time it takes for the ball to go from point A to point B is a certain time, right? So for it to go from point A to C, it's just 2 times that time. Okay? So to make things easier, I'm going to figure out part C first. Okay. So let's do part C. How much of the time does it take to go from point A to point B? Okay. So again, I'm just using this path from point A to point B. I'm still looking at this. Same thing. Okay, so now I have V naught still 10.0 meters per second. I have, let's see, A is negative 9.8 meters per second squared. T, that's what I want to find. V. At the top, V is 0. So out of these 5 equations, this one is the simplest. So I'm going to use this. I'm going to use this equation. You can also use this equation too. You have all the information, but I think this is the simplest, so let's do that one. Okay, so just plug in the numbers. V is 0 at the top. So 0 equals to 10 meters per second minus 9.8 times t. I'm going to add the 9.8 t over. 9.8 t equals to 10.0 meters per second. T equals to 10 divided by 9.8, 1.02 seconds. Okay. So it takes 1.02 seconds from the ball to go from point A to point B. So then we can just easily do part B. How long is the ball in the air before it comes back? It's just going to be 2 times t. So part B, it's just going to be 2 times t. So this is from A to B. So from the whole path, it's just going to be 2 times t. So that's 2.04 seconds. Again, it's because the motion, there's a symmetrical motion here. Okay. So now let's turn to part D. What is the velocity of the ball? What is the velocity of the ball as it goes down back to the thrower's hand? So what is this velocity when it goes back to the woman's hand? Okay, remember that I told you that at the same height, it's just going to be equal and opposite signs. So if this is right here, it's initial 10 meters per second up, then down at the same height, it's at C, it's going to be negative 10 meters per second. But let's use the kinematic equations to figure it out. I'm going to look at now the whole path. Okay, so usually I've been saying pick the y direction according to the direction of the motion, but here, you know, you have an upward motion and a downward motion, so choose either one. So I'll just choose upwards as positive y. Okay? Okay, and acceleration of gravity is always negative. So I'm looking at this whole path now. V naught, what is V naught? V naught is the initial velocity. So that's at A. At A, the initial velocity is 10.0 meters per second, and that's positive because it's going up. So that's positive 10.0 meters per second. What else do we know? Y naught is where it starts. We're going to make y naught 0 here where it starts. Okay, so the interesting thing about this one is, what is y? What is the y height? The final position. The final y position. Does anyone... This is her hand right here. What is there a difference of height here? No, there's no difference of height. So this is 0 and it goes back down to 0. So y is 0. Okay? So we're trying to find v. So we don't know this yet. What is v? So then you look at the 5 equations. you look at the 5 equations and you figure out which one you want to use. And again, this one seems like it's the easiest. Let's see if we have everything. So we have V naught, we have A here. A is negative 9.8 meters per second squared because we made positive in the y direction. So acceleration is negative. It's always downwards. Okay. Do we have time? Time now is the whole path because we're looking at the whole path. So we calculated time. Time is the whole path, which was 2.04 seconds. Okay, so always draw the drawing because you want to know, you need to make it clear what direction is y, what path you're looking at. So make sure you don't skip steps. Okay, so we have V. So we have everything we need to find V. Okay, so V equals to 10.0 meters per second plus negative 9.8 meters per second squared times time. V, let's put that in our calculator. 10 minus 9.8 times 2.04. Velocity is negative 0.992, which sig figs, it's, yeah, so it's around, well, so it's by the sig figs, let's do negative 9.99 meters per second, which that's basically negative 10 meters per second. Okay. Okay, so we showed that the initial velocity of 10 meters per second is the same as going down, as it going back to the person's hand. Also 10 meters per second, but negative, downwards, negative 10 meters per second. Okay, so yeah, we're done with this problem.